Well, question 4 says for each of the following number patterns, determine the general term or the nth term and hence the 150th term. All right. We did so many so many examples on the term of determining the quadratic pattern, the Tn form, and also to a certain value. So I won't really do these questions, except I can do question G and H because these last two seems to be quite challenging. Now let's go from we do G here. G says like the pattern is 3.5. Okay, and then 10. Now I would like to write those mixed numbers. Okay, let's just leave them as they are, 3.5, and then 10.5, 21.5, and then 36.5. Okay, I can leave them like that. We can still do that. We're going to find the first difference, D1. Okay, so 10.5 minus 3.5, this is just equal to 7. Okay, 21.5 minus 10.5, this is just 11, and 36 minus 36.5 minus 21.5, this is just equal to 15. And then the first difference will be, the first difference is that pattern, and then the second difference will be 4 and 4. So it will be a constant pattern. Now, the fact is, the constant pattern, this proves that the given pattern was a quadratic pattern. Then we can say that Tn is n squared minus an squared minus bn plus c. No, plus bn plus c, that general formula. And then a is the second difference over 2. 3a plus b equal to t2 minus t1. And then a plus b plus c equal to t1. Now we can solve a. Okay, a will be equal to the second difference over 2, 4 over 2, a is 2. And then 3a plus b equal to what? A, we did find that a is 2, and then that makes 7. So that makes 6 plus b equals 7. So if I minus 6 both sides, I'll have b equal to 1 there. So I have like a and I have b. Then over there, we can substitute the values of a plus b plus c equal to t1. A is 2, b is 1, and then t1 is, the first term is 3.5. Now, this makes like 3 plus c equal to 3.5. If we minus by 3 both sides, we have c equal to a half. So we have like a, b, and c. Then we can say, therefore, Tn will be equal to what? 2n squared plus n, 1n just n, plus a half, that's Tn. Then we can find the 150th term by substituting 2n squared plus n plus a half. Okay, so we can substitute 150, 150, 150. You can use a calculator for that. And then what we have, 2n squared, so n is 150, plus 150 plus a half. Okay, it's equal. And then that means that T150 is just 45 150 and a half. Okay, that was G. Okay. And then we're going to do H, which is actually the challenging question. Okay, this one, let's H. when you see this, that star stands for a challenging question. So we're like 2/3, and then 5/6, and then 10/11, and then 17/18. So now we need to solve this. How can we? Mm, we could change the fraction to the same denominator, but it's gonna be a lot of work here. Okay, because we have like 3, 6, and 18. They all have 18 for common denominator, but with 11 we have to times again 18 by 11 to get the common denominator here. Maybe we can do that, or maybe not. So we can just do find the difference here, the difference there also. Okay, we can do 5/6, 5/6 minus 2/3, and then this is equal to 1/6. Okay, and then we can also do 10/11 minus 5/6, and then hit equal there. That makes 115, not plus, but minus the difference. So this is 5/66. Okay, and then we can do also 17/18, minus 10/11. Okay, and then hit equal. That makes 7/198. Now we cannot really tell that this is a linear pattern yet because of the the difference. The fractions looks quite complicated to tell. Now let's just do the second difference now. It's gonna be again 5/66. Excuse me. 5/66 minus 1/6, and then this is equal to what? This is negative 1/11, negative 1/11, and then let's see if we're gonna get 7 over no 7/198 minus 5/66, and then this equal to -4/99. Now we can say this is a quadratic pattern. Okay. We cannot say because the second difference here are not common. They're not common. That was D1, D2. Okay, the second difference are not common. What else can we do then? I prefer to observe the pattern the way they are. Here we have like 2, 5, 10, 17. Okay, let's try to solve them separately, the numerator and then the denominator, because this is another way of finding the pattern. So this is definitely, this pattern is not quadratic. Okay, now what we can do, if I look at the numerator here, 2, 5, 10, 17, I notice one thing. The square numbers are let's move a little bit down. The square numbers are like 1 squared, 2 squared, 3 squared, 4 squared. Okay, so now if I plus 1 here to this 1 squared, I'll get 2, because 1 squared plus 1 will be 2. And if I plus 1 also here, it gives me 5, because 2 squared is 4 plus 1 is 5. If I plus 1 there, we have like 9 plus 1 is 10. If I plus also 1 over here, that makes 16 plus 1, that's 17. So at the numerator there, we have like square numbers plus 1. Now let's look at the denominator. Okay. The denominator here, if I do the first difference, let's just see. We check it. If I do the first difference here, what am I getting? 3, 5, and 7 at the denominator. Okay. Then it's visibly a linear pattern because another difference here would be like 2, 2. So this is a linear pattern. Then we can say at the denominator here, we can then say at the denominator, this will be Tn, linear pattern. Remember how we do? We're gonna look at well, I'm saying the denominator here makes a quadratic pattern, I mean, not a linear pattern. So over here then, we do know that the quadratic pattern Tn is given by an squared plus bn plus c. That's the quadratic pattern. And now that's a is the second difference over 2. And then 3a plus b equal to the difference of the first 2 terms, t2 minus t1, and a plus b plus c equal to t1. Now let's do it. A will be equal to d2 over 1 over 2. So a is 1. 3, a plus b equal to a is 1. And then t2 minus t1, we find it to be 3. And then that makes 3 plus b equal 3. So if we move, we minus 3 both sides, we have like b. B equal to 0. Okay, and then there we have like a, which is 1, b is 0, c is equal to t1, which is 3 at the denominator. So a was 1, b is 0. So if we move 1 over or minus 1 both sides, we have like c equal to 2. So now, because of this, we can say Tn will be equal to an squared, 1 n squared plus 0 plus 2, which means Tn equal to n squared plus 2. We could also, I say we could also do something similar to what we did at the numerator there, because this is a quadratic pattern. We can also do like, let me just move this formula over here. We could also look over here. We have the number 3. Okay, so the square numbers we know are like 1 squared, 2 squared, 3 squared, and 4 squared here. Okay, now if I have 1, to get 3 there, I need to plus 2. Okay, there I'll plus also. To get 6, I must plus 2. To get 11, I must plus 2. Okay, there also 2. So like 1 squared plus 2 is 3. 2 squared plus 2 is 6. 3 squared plus 2 is 11. 4 squared plus 2 is 18. We could also do the same thing like that. And then notice that over here, the denominator makes something of the form n squared plus 2, and the numerator makes something of the form n squared plus 1. And then say the numerator over the denominator. So over here, it will be, therefore, Tn will be equal to n squared plus 1 over n squared plus 2. Thank you.